Okay, so today we are going to be looking at uh, the homework assignment for the third session of the MATLAB and Simulink workshop for Best Robotics that I've been participating in. And today um, we are basically creating a robot that's going to, in our virtual environment, so let me just run it for just a second, just to show you the virtual environment. Um, Okay, so let me maximize this real quick. So in our virtual environment, what we want our robot to do is to go forward and then basically walk around the perimeter. And once it is finished walking around or not once it is finished, but after 20 seconds of running this program, we want it to switch directions and go the other way. So what I did was I started off with an exercise that we had already completed in class, and that was called track wall. And the solution for track wall, I can open up real quick. Solution for track wall is here. And looking at the solution for track wall, we see that we're using these switch blocks, which are kind of acting like this if statements. So if the middle, if the second input is satisfied, then the first, so we're setting a threshold here, but if that second input is satisfied, then we carry through with the first output, input, and if or else we carry through with the second input. So that's the value that we provide. And then same thing. So this is if we're moving forward, and then the other one right here is turning right if the wall is too close. But what we want to do in ours is we want to do this, but then after 20 seconds, start turning left if the wall is too close. So what I did was I copied that, and then I just added this digital clock block here that's available in Simulink. And then I created a MATLAB function that reverses the direction after 20 seconds. So let's take a look at that function real quick. So what this says is I'm creating a function called steer, and it's a function of time. And what I'm saying is if time is less than 20 seconds, then we're going to steer 50, meaning we're going to continue in the clockwise. Yes, we're going to continue turning right. So we're going to continue in the clockwise direction. Else, meaning after 20 seconds is up, we're going to start turning left. So it's a very simple MATLAB function using the input time and output steer. I can, let's see, let me just go ahead and save this one more time just to make sure. I'm not going to close it, but let's open up the MATLAB or the Simulink again. And as you can see, we have our input time, which is coming in from the digital clock. And if we open this up, we see that it outputs the current simulation time at the specified rate. And we're going to just keep it sample time of 1. And then the output is a steer, and then the steer we said was 50 or negative 50, depending on the 20-second threshold. And then that is basically the else in this statement, in this switch statement, or switch block rather, which is saying that if the sensor, so we're using a distance sensor here, right? So if the distance sensor is greater than 1, then obviously our left and right should say 0. And if it's not greater than 1, then we want it to turn, right? Because as we get closer and closer to the wall, it's going to get less than 1, the distance. So it's going to get less than 1, and we want our robot to turn. So that's when this function starts applying, where we'll start turning right, except after 20 seconds, then we'll start turning left. So let's just take a quick look at the program and see how it runs. So as you can see, it started turning, and we're still going to start following the wall pretty closely. And you can track the time in the bottom right corner right here where it says time. We're almost approaching 20 seconds. We got 5 seconds left. It's continuing to turn, and it's 20 seconds. So now, as you can see, the robot is turning left, and then it'll continue following the perimeter counterclockwise instead of clockwise. And right now I've set the stop time to infinity, so it'll keep doing this program forever. But you get the idea. So I'm going to go ahead and stop the simulation, and that's pretty much it. So it's a pretty simple program. We're using the same arcade block that we used in the last homework, same left motor, right motor, same obstacle environment. The only new things basically are the robot, the distance sensor that we're using here. Let me just go ahead and show the block name, that way that stays. The distance sensor, we are using the switch block, and then we're using the MATLAB function, and then the digital clock. So these are the new things that we're But that's pretty much it for this lesson.